Hi everybody, this video is about solving quadratic equations by taking roots. Now, we've actually already covered a more complicated method for solving quadratic equations, that is, solving quadratics by factoring. I wanted to jump into the deep end and cover solving quadratics by factoring and then backtrack to this example, which is actually easier. So on the right side of the screen, you see a two-step process. In step number one, you isolate the quadratic term. Now, I wrote x squared because we like to use x as our variable. In this problem, we're using v as the variable. It's the same thing. So you want to get the quadratic term, the square term by itself. And once you do that, you take the square root on both sides. There's one small technicality that we'll get to, and that's how you solve quadratics by taking roots. So in this problem, the first thing we do is we subtract 10 from both sides. So we're going to have v squared is 25. And then you take the square root of both sides. Now, the thing is, when we take the square root of both sides, the square root of v squared is v, and you might be thinking, well, the square root of 25 is 5. However, every number, with the exception of 0, has two square roots, a positive or principal root and a negative root. So the square root of 25 is 5, but negative 5 is also a square root of 25. Because negative 5 times negative 5 is positive 25. The general rule in math is if you introduce a square root into a problem, so if you take the square root on both sides of this equation, you have to consider both roots. However, if you're reading a math book or doing a math problem and there's already a square root, so let's say you pick up a math book, you open it, and you see the square root of 81 on the page, you can conclude that the author meant 9. The principal or the positive square root of 81, which is 9. If the author had intended you to consider negative 9, the author would have written negative square root of 81, which is negative 9. However, because we introduced the square root in this problem, the author did not. Since we introduced the square root, we do have to consider both. And remember, or please note, this symbol, plus or minus, all that means is this equation has two solutions, negative 5 and positive 5. And that's really it for solving quadratics by taking roots. I'm going to do a couple more examples because you do have to be able to work with square roots. So let's do that. So here we'll follow the same two-step process. Let's isolate the quadratic term. So we're going to add 6 to both sides. 62 plus 6 is 68. Now take the square root of both sides. So b is plus or minus the square root of 68. Well, now we have a problem because we never are going to write the square root of 68 as an answer. Assuming you're watching this video and you're in my class and you remember the first semester, we always simplify our radicals whenever possible. So if the numbers are not too big, perhaps you can do this in your head. If the numbers are big, perhaps you need a piece of scratch paper. Maybe you go off to the side and you do some factoring. You make a little factor tree and you say, well, 68 is 2 times 34, and 34 is 2 times 17. However you get there, you do have to think in terms of factors. So if you don't remember this, we have plus or minus the square root of 2 times 2 times 17. And to make a long story short, but again, if you're in my class, this is old news. If you have 2 copies of a number inside of a square root, that's going to come outside as a single copy. So you have plus or minus 1 copy of 2 outside. The 17 has to stay inside. And remember, this does mean 2 answers. We have positive 2 times the square root of 17 and then negative 2 times the square root of 17. So you do have to remember how to simplify roots. Let's do a couple more and just see what happens. So here we have a two-step equation to solve this time as our first step. So Let's subtract 7 from both sides. We have 64b squared equals 56 minus 7 is 49. And now let's divide by 64 on both sides. 49 over 64. That does not reduce. And the way you take the square root of fractions is probably exactly how you would think. You take the square root of the top, square root of 49 is 7, take the square root of the bottom, square root of 64 is 8, and you're done. If it were the case that these were not nice whole number square roots, if you had to keep the square root symbol, you would simplify your roots, as we did in the previous problem. Okay, I think we have one more. Almost exactly the same. Just be careful of your minus signs. So I'm going to subtract 9 from both sides, and here's why you do have to be careful with your arithmetic. Negative 187, and since we're subtracting 9, this is negative, what's that going to be, 196. And then when you divide by negative 2, let's see, 196 divided by 2 is, what's that, 98, I suppose. Positive 98. Take the square root on both sides. So n is plus or minus the square root of 98. And once again, if you need to go off to the side and make a little factor tree, please do this on scratch paper. You don't need this interfering with your algebra problems. I think 98 is 2 times 49, and that's enough factoring. Since 49 is a perfect square, you have n is plus or minus the square root of 2 times 49. Well, you can just take the square root of 49, that's 7. So you have plus or minus 7 times the square root of 2, and you're done. Now, I wanted to stop at this problem and just do a what if. Let's pretend for a moment that this first minus sign was not there. What if this problem just said 2n squared is negative 196? Well, when you divide by 2 on both sides, you get n squared is negative 98, and here you're stuck. We're actually going to say that this problem has no solution, and that's because you can't take the square root of a negative number. The reason the square root of 49 is 7 is because 7 times 7 is 49. Well, let's just say that negative 98 did have a square root. Well, if it was a positive number, a positive times a positive will be positive. It can't give you negative 98. If the square root of 98 was a negative number, again, negative times negative is positive. It can't multiply by itself to give you negative 98. So for now, you can't take the square root of a negative. Just put an asterisk next to that in your head. When you get to Algebra 2, you'll learn about a different type of number, and actually this equation does have a couple of solutions, but you don't have to worry about that in an Algebra 1 class. Anyway, that's how you solve quadratics by taking square roots. Hope this video helped.